So this video is on dimensional analysis, particularly dimensional analysis with rates. So far we've only been converting just plain old measurements like 5 miles, but some of the things we can measure, like some of the things you all named the other day, are rates. Something like miles per hour, which would be a speed, or different things like that. So when we convert a rate, we'll convert it the exact same way as we did with just something like 5 miles, which is technically 5 miles over a 1, and so it's basically the same thing. Remember, this process where we use conversion rates and we multiply is called dimensional analysis. Okay. So we're just going to go through 5 examples. The first one is apparently the average 40 time, which is a 40-yard sprint, for wide receivers in the NFL is 4.55 seconds. We're going to convert that to miles per hour. See how fast they're running. So they are going 40 yards in 4.55 seconds. We want to convert this to miles per hour. So 2 things needs to happen here. I need to go from yard to mile, and I also need to go from seconds to hours. It doesn't matter which I start with, but both are going to need to take place. I don't know how many yards are in a mile. You might. That's great if you do. But what I could do instead is go from yards to feet and then feet to mile, because I do know both of those. And then I don't know how many seconds are in an hour. Again, you might. That's great. Use that. But I think I'm going to go seconds to minute and then minute to hour. I'm going to go feet. Okay, so that's just kind of my general plan. Let's start with yards to miles. You can start with either, but I'm going to multiply by a conversion factor, first of all, just to get yards to feet. Since yards is on the top, I need yards on the bottom in my conversion factor. Going yards to feet. In 1 yard, there's 3 feet. And now I can go feet to mile. I know in 1 mile, there's 5,280 feet. All right, so now yards is canceled, feet is canceled. If I were to multiply all this out and divide as it is, it would currently be in miles per second. That's not really what I want though. I want miles per hour. And so now that I'm in miles, that's good, but I need to convert seconds to hours. So we'll need a few more conversion factors. First, I'm going to do seconds to minute. It's tempting to put seconds on the bottom, but actually seconds is on the bottom right here. So if I want to cancel it out, I need seconds to be on the top, so that seconds and seconds will cancel each other out, and I'm going seconds to minutes. I know that 1 minute is 60 seconds. So now seconds cancels, and I'm in miles per minute. I need 1 more conversion. I need to go from minutes to hour. Again, since minutes is on the bottom, I need it to be on the top over here. Sorry, I'm running out of room. Minute to hour. I know 1 hour is 60 minutes. All right, I'm finally good to go because minutes cancels, and what I have left is miles per hour. So, with all this mess, these are still just fractions. So like you do with any fractions, you multiply straight across the top and see what you get, which that is 40 times 3 times 1 times 60 times 60. So on the top, I got 432,000. On the bottom, just multiply across, and you get 24024, and then divide them. So we get 17.982 approximately. Remember, this was miles per hour. That feels really fast, but I guess they are wide receivers in the NFL, so that makes sense. This was miles per hour, or another way to write that is mph. All right, so that is my final answer. You could round that up to 18 if you wanted to. For our next example, we're going to talk about how many words can you read per minute. So I'm actually going to have you time yourself. Here is a just passage to read. Take 30 seconds and time yourself. See how far you get, how many words, and then double it. That's how many words you could read in a minute. So go ahead and pause and try that. Okay. All right, so let's say you could read 200 words per minute. Word per minute. What if we wanted to see, like, if you kept reading at that same pace for a full hour, how many words could you read? So that would be 200 words per minute. And we want to change minutes to hours. So we could just do a quick little conversion here of minutes to hours so that minutes cancels. In 1 hour, there's 60 minutes. And so I would do 200 times 60, which is 12,000. You probably couldn't keep that up for a full hour constantly, but if you could, that'd be a lot of words in an hour. This is a true story, by the way. Kind of interesting. All right, example number 3. How far could you walk in a day if you never took a break? So again, time yourself for maybe like, I don't know, 5 seconds. Here, I'm gonna see how far I can go. 1, 2, 3, 4, 5. I made it, it looks like 10 squares on the floor, so 10 feet. So I made it 10 feet in 5 seconds. That was my speed. How far could we go in 24 hours? So first of all, let's just turn this into like maybe feet per hour. So I'll turn seconds into minutes, and then I'll turn minutes into hours. So I know there's 60 seconds in a minute, 60 minutes in an hour. Multiply that out, and we've got 10 times 60 times 60, which is 36,000. Divided by 5 times 1 times 1, so divided by 5. And that gives us 7,200. Remember, that was how many feet I could go in an hour. That's what we're currently at. So if we never took a break, if we went for 24 hours, this is how many feet I could go in 1 hour. To get to 24 hours, just multiply by 24. Or like think of that as part of this, just multiply the whole thing by 24. Multiply this by 24. So let's see. That would be 172,800 feet. You may be interested what that is in miles, because that's a lot of feet. So if we wanted to convert that to miles, I know there are 5,280 feet in 1 mile. And so feet would cancel, multiply, and then divide. And that is, oh my goodness, 32.72 repeating miles. So that's how many miles I could go if I kept up that same pace for a full 24 hours. I could walk 32 miles over a marathon. warn you, sometimes you'll see this stuff written not as fractions, but written as boxes. So something like this. It literally is the same thing, just as a box rather than as a fraction, but you know what to do. Sometimes you'll be asked to fill in these blanks, so just be aware that that might be coming. All right, 2 more examples. This is real, by the way. In 2018, TikTok was downloaded onto someone's device 667 million times. So on average, how many times was it downloaded in a day? Let's think about this. So this is 667 million. Actually, why don't we go ahead and turn that into an actual number, because that'll help us for our calculations. So million would mean it has 6 zeros, because that's the millions place. So it was downloaded, that many downloads per 1 year. That's how many downloads we had in 1 year. If I want to turn years into days, some of you may have figured out just divide by 365, and that's fine. If you want to do it whatever short ways you have, that's totally fine. But if you want to use dimensional analysis, we would convert year to day, and I know in 1 year is 365 days. Multiply across the top and across the bottom, and then divide. So basically we're dividing this by this. So I got 1827397.26. I'm just gonna round it. Wow, that is big. Over 1 million downloads per day, almost 2 million downloads per day. What if we wanted to change this to hours? This was downloads per day. Download. If we wanted to change it to hour, we would need to divide each day into 24 hours, or convert day to hour. 1 day is 24 hours, and then multiply across. I'm going to use that original amount. And divide it by 24. Wow. There's some other decimals on there, but it's about 76,000 downloads per hour on average. Isn't that insane? All right. Last example. I've heard that this is true, but I got this off the internet, so I'm not sure how exactly accurate this one is. Apparently, 1 can of Spam, oh no, 1 can of Spam is opened every 4 seconds on average. So how many times is that in a day or in a year? So that would be 1 can every 4 seconds. All right, I've actually been to the Spam Museum in Minnesota. It's a weird place. Currently it's in cans per second. I want to know how many in a day. So I can convert seconds to maybe minutes, and then I could convert minutes to hours, and then I could convert hours to day. So 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. Multiply across the top, and you get that's on top, but on the bottom it's 4 times 1 times 1 times 1, so 4. And then divide, and you get 21,600 cans of Spam. That is now in days. If we wanted to go year, we could just multiply this by 365, because there's 365 days in a year. I got 7884000, 7,884,000 cans of Spam. Again, I don't know how accurate that one is, but it's a lot of spam.